Theorem 8 is the monotonic sequence theorem. Every bounded monotonic is convergent. So every sequence that has a bound, an upper bound or a lower bound, it doesn't get bigger than a certain value or drop below a certain value. And monotonic, strictly increasing or decreasing, we know it is convergent. Now the proof of that is fairly involved. I'll go through the example in the textbook, possibly do one more problem, and then ask you to try one or two in homework. It starts out with a recursive definition. So this particular pattern is not an nth term formula, but the first term, and then a description of how to get the next term. So the nth plus 1 term is equal to 1/2 a sub n plus 6. So to get the next term, take the previous term and add 6, and then cut it in half. We can do that on the calculator. It doesn't prove anything in particular, but we can actually show it. Let me zoom in on the calculator. If we hit a 2, here's how we create a recursive definition. I want to add 6 to that and then cut it in half. So I will use a parenthesis and say that previous answer plus 6 divided by 2 is the formula to get the next term. I press enter. I get 4. I get 5, 5.5, 5.75. And it does look like it's climbing and heading towards 6, but should stay less than or equal to 6. Let me zoom back out. Let's walk through the proof on how to carry this out. It makes use of the idea of induction. We need to establish that the second term, how does that compare to the first term? And of course, if I put 2 in here, 1/2 is equal to 1/2 times 2 plus 6. 8 cut in half is 4. So it does look as if this sequence is climbing. So a sub 2 is bigger than a sub 1 because 4 is bigger than 2. So our first proof that we will carry out is that it is increasing. Of course, this is true for the first pair of terms. How do we show that it continues to increase? Well, we need to show that the nth plus 1 term is bigger than the nth term for all n greater than or equal to 1. We just showed that it was true for n equals 1, that the second term was bigger than the first term. And now we begin by assuming it's true, that this statement is true for n equals k. In other words, we're going to assume that's true for a sub k plus 1 bigger than a sub k. And we'll show that if it is, it's true for the next pair. And so there's a domino effect. Again, we are assuming that a sub k plus 1 is bigger than a sub k. And what we hope to arrive at is the a sub k plus 2 has to then be bigger than the a sub k plus 1. what we basically do is create the formula by taking and performing the two algebraic steps that the formula included. Add 6 to both sides. We're talking about the recursive part. So I take the a sub k plus 1 and I add 6. And again, the formula was take the previous answer and cut it in half. So I'll multiply both sides by 1/2. And what have we arrived at? Well, this is saying take the kth plus 1 term, add 6, and cut it in half. Well, by definition, that's the next term. That is a sub k plus 2. And likewise, if I take the kth term, add 6, and cut it in half, we are applying the recursive formula, and that arrives at the next term. And what we've arrived at is that if it's true that a sub k plus 1 is bigger than a sub k, then it is certainly true that a sub k plus 2 is bigger than a sub k plus 1. In other words, if it's true for a pair, next term bigger than the one before it, we're guaranteed the next pair will also hold that a sub k plus 2, the next term, is bigger than the one before it. We still need to show that it is bounded, and we also need to conclude what the limit should come out to. And we saw off of the calculator before that it neared 6. It was 5.99, and in fact, if we kept pressing enter by rounding, it would get us there. It would get us to 6 and then stay there. So we know that visually it looks like they're going to stay smaller than 6. How would we conclude that? Well, again, we begin by saying suppose that our statements are true for n equals k. In other words, that we have a term smaller than 6. We need to show that the next term is smaller than 6. Once again, we simply carry out the recursive part of the definition. Let's add 6 to both sides. So a sub k plus 6 is smaller than 12. Cut it in half. And by definition, this is the a sub k plus 1 term. And that tells us that if we have a term smaller than 6, and we did at the beginning, we are guaranteed the next term will be smaller than 6. One more thing.